Okay, so the first side says writing equations of lines. So we're right over here. Let me grab my pen. It says writing an equation of a line given m and b. So if we have this equation right here, this is our slope intercept form equation. So the reason this is called our slope-intercept form is because we have y is equal to mx plus b, where m represents our slope, m is our slope, and b represents our y-intercept. And what we mean by a y-intercept is if we have a graph of a line that looks like this, so the red graph, this point right over here where the graph and the y-axis, because this is our y-axis, where these two meet right over here is called our y-intercept. Okay, so we're using our slope and our y-intercept to represent a line using the equation y is equal to mx plus b. So if we're given our m and our b, so our slope and our y-intercept, all we have to do is, well, let's follow the steps. Write down your y is equal to mx plus b equation. Step 2 says substitute slope for m and y-intercept for b. So m is our slope, -5. So y is equal to -5 times x. And y-intercept is 2, so plus 2. Simplify the equation. Well, can't do anything about that here. We're all good to go. So this is my answer for number 1. Number 2 is slope is -1/2 and y-intercept is -2. So y is equal to -1/2 x plus -2. We can simplify that by saying y is equal to -1/2 x, and these two plus and negative combine to give you -2, or subtract 2. So that's your final answer for number 2. Number 3 says slope is 0 and y-intercept is 3. So y is equal to, my slope is 0 times x plus my b is 3. We can simplify this because remember, whenever you multiply any number by 0, you get 0. So this whole term becomes a 0. 0 plus 3 is just 3. So this is just y is equal to 3. And example 4 is 1/3. Our slope is 1/3 and y-intercept is 0. So y is equal to, our slope is 1/3 times x, and our y-intercept is plus 0. That simplifies to y is equal to 1/3 x, and we can drop the plus 0 because any number, if you add a 0 to any number, you just get that number itself, which is 1/3 times x. Okay, so let's look at the problems underneath. These ones right over here. We'll do a few together. It says writing an equation of a line given a graph. Write down y is equal to mx plus b. We'll write it once up here. Y is equal to mx plus b. But we don't have a lot of space, so we're not going to write it every single time. It says use any two good points on the graph to find the slope m. So what they mean by good points is wherever you have an intersection of your y line and an x line, and your graph goes through exactly that intersection, is a good point. So if we look at this right over here, this y-axis and this x-axis right here, it'll show up better on your printout than it does on my paper. But yeah, this point right here is a good point because you can tell exactly where it lands. This point is on 0, comma, positive 2, right? If you were to pick this point right here, it doesn't really have an exact value. We're not sure, like it might be 1.75 and maybe 3.2. We're not sure. So that's why that's not a good point. Now, if we follow the graph, if we keep following it further and further and further up, this point right here, again, crosses at this intersection of this y line and this x line, right? This y line and this x line, where the x is 5 and my y is 6. So that's another point. So we picked 2 points to find the slope. So how we find slope, again, that's on page 39 of our ISN. All you're going to do is take rise over run. So for this, we have 1, 2, 3, 4 units up, going 4 units up, and we're going 1, 2, 3, 4, and 5 units to the right. Both of those directions going up and going to the right are associated with positive movement. So this is a positive 4 and a positive 5, and that is my m. Again, my m, or my slope, is found on a graph by using rise over run. So that's what we did here. We found our m. And then again, our b is just where our graph and our y axis meet. So if we look at that right over here, this graph over here and this y-axis right here, they meet right at this point, which is a positive 2. So my b, or my y-intercept, is 2. So now we're going to take these two things and plug them into our equation. Y is equal to mx plus b, or y is equal to 4 over 5 for m times my x plus my b is 2. That's our equation. Substitute slope for m and y-intercept for b into the equation. Y is equal to mx plus b, which is what we just did. I'll let you do this one on your own. We'll do this one together. So again, I am going to pick this point right here because it crosses exactly at that y-axis, which is 0. And then this x or y, when my y is equal to 2. So this point right here is 0, 2, right? And then if we keep following it down, keep going, oh, right over here is another good point because the graph crosses at the intersection of 1, negative 1. Negative 1. So those are my 2 points, and to go from this point to this point, we're going to do rise over run again. 1, 2, 3, rise is 3, but we went down, which is a negative movement. So negative 3 over 1, or 1, which equals negative 3. So my slope is negative 3, and my b is this point right here. Again, it's 2. So we have our m, we have our b, and we can replace those values in our equation, which gives us the final answer of y is equal to negative 3x plus 2. If you look at these 2 graphs or lines over here, graphs, line, same thing, right? If we were to find the slope of this line, it would be rise over run again. So if we pick 2 points, again, 2 good points, if this one and this one right over here, because this one falls on the y-axis and this line right over here, and this one falls on this and this line right over here. So what's our rise? To get from this point to this point, how far do we go up or down? Well, we go 0 places up or down, right? So my rise is actually 0, and then my run is 1 and 2 units. But any number, when you divide a 0 by any number, you get a 0. So our slope, or our m, is actually 0. And then my b is, again, where my line crosses my y-axis, which is at this point right over here. So my b is 3. So my m is 0. Y is equal to 0 times x plus 3. But any number multiplied by 0, again, gives us a 0. So our equation is y is equal to 3. What this tells you is for any number that you pick on the x-axis, so if we say, let's say 4 on the x-axis, well, what does my graph, where is my graph on the y-axis when my x is 4? Well, if we look at the graph, my y is at 3, or sorry, my graph is at 3 on the y-axis. If we were to pick -5 on the x-axis, where's my graph on the y-axis? Again, if we go up to it, it's at 3. So for any point on the x-axis, your y is always going to be 3. That's what this says right over here. Y is equal to 3. And that is our answer for this line, or the graph of this line is represented by this equation. Now, if we look at the vertical line right over here, for every value of x, we have our y is 3. So in that same manner, if we look at this, for any value of y, no matter what you pick, 6, when your y is 6, what is your x going to be on the graph? Your x is going to be -6. For any value of x, again, 0, if my x is 0, my y, or sorry, if my y is 0, my x is still -6. If my y is -3, my x is still -6. If my y is -6, my x is still -6. So this equation for this line is simply x is equal to -6. Again, that's an x, not a y. X is equal to -6. That just means any y point you pick, your x is always going to be -6. So now let's look at, actually, I think that's good. I think I want you guys to do number 6, 8, 11, and 12 on your own. Okay. Good luck.